Hello guys, welcome back to my channel, and in today's video I'll be going through some of my predictions for the IGCSE Physics paper 4. I know you guys have your exams coming up in a few days, so I wanted to drop this video so that it would help you. So in this video I'll be going through some predictions, and I've gone through a lot of past papers and looked at some interesting trends, and I'll be going through that in this video. And if you're new here on this channel, I'll be doing IGCSE physics related content. So I'll be doing past papers, topic questions, and overall revision. So make sure to subscribe for more upcoming videos. So the first topic is physical quantities and measurement techniques. Now this has a 5%, takes 5% of the paper, and on average it has 3 marks 3 marks, but then when it comes, sometimes it would come with 4 marks or more. So what they ask is, the first one is the use of different apparatus, but this is very uncommon, so you shouldn't expect this. The most common type of question they would ask is scalar and vector quantities. So this is very common. Whenever this topic comes, it's rare for this topic to come, but whenever it comes, it's it's mostly scalar and vector quantities. So what you need to do is they would give you a diagram, and they would ask you to determine the resultant force or the resultant vector from diagrams. So these two topics are what you should watch out for. If you don't know exactly how to do this, I would link down a video that I did before on how to do this type of question. Now the second one is motion. So motion takes up about 9% of the paper. That's around 5 marks per paper. So what they usually ask you is to calculate velocity, acceleration, and distance, usually from different types of graphs. So you are required to know the different types of graphs, different type of motion graphs. We have the speed time graph, and we also have the distance time graph. So you should know these, and then you should you should understand what the gradient means, what the area under the graph means. If you don't know this stuff, I have a video down below that goes through everything you need before your IGCSE physics exam, so make sure to check that out after this video. You also need to know the formulas to calculate velocity. So velocity is distance over time, acceleration is change in velocity over change in time. So these formulas you would need to know, and if you don't know them, again, I have a video down below in that description that would go through everything. The third topic is forces. So it consists about 10.5% of the paper, and it's 6 marks. So what's interesting about forces is, like, it's embedded in multiple questions. So you can see it all over the paper. So what they can ask you is about mass and weight. So you should be able to determine what mass is, and maybe they've given you the weight, and then you should be able to divide the weight by 9.8 to find the mass. The next one is density. So you should know that the formula for density, which is mass over volume. And the third one is turning effect of forces. Now this is mostly moments. You should also know what the principal conservation of moment is. So what is the principal conservation of moment? So this is the sum of clockwise forces, or the sum of the clockwise moment is equals to the sum of anti-clockwise moment for an object in equilibrium about the same pivot. You should also understand the concept of center of mass. It's a point where the weight of the object acts upon, and also momentum, and how momentum is related to forces. So we have different formulas for momentum. The main one is mass times velocity. So you should be able to understand this. and there are more formulas for forces. So I've gone through all of those formulas in my crash course video, which I'll link down in the description. The next one is work, energy, and power. So it takes about 11% of the paper, so around 7 marks. So work, energy, and power questions are usually embedded under forces questions. So they usually ask you the different types of energy, usually kinetic energy and gravitational potential energy. Now they usually ask you to calculate the GPE and the KE after like a forces question. So maybe at the end of a forces question, expect to see like a calculation for kinetic energy or gravitational potential energy. Now, energy sources. So these types of questions have been becoming popular over the years, and they've been coming up a lot. So they could ask you to compare between different types of energy. What are the advantages of the one of them, and then disadvantage, and you should know which one is more suitable to use in a certain situation. The next one is work done and efficiency. Now this is becoming less popular. Work done and efficiency, especially efficiency. So in the past year or so, there's only one question that came up about for efficiency and for efficiency especially. So it's rare, but then it could come up. So make sure to prepare for it. Now power. So power, the formula is work done per unit time or the energy transferred per unit time. So make sure you understand these two formulas. Pressure. So this topic has been decreasing in popularity, and the number of marks it holds are also decreasing. So we're looking at around 6% of the paper, and which is about 4 marks per paper. So when it comes, what they ask you is the pressure in solids and liquid. They could ask you to calculate pressure in solid and liquids. So in solids, pressure in solid is force over area, and pressure in liquids is density times gravity times height. You should know these two formulas. They're very important. And you should also know how area affects pressure. So since they're inversely proportional, as area increases, the pressure decreases. You should be able to manipulate this relationship and answer some questions. And the next topic, it's thermal physics. So this is one of the big topics, and it takes about 13% of the paper, which is about 8 marks. So it's really important to understand this topic. So what can they ask you is the first one is states of matter and particle model. Now this has not been very popular in recent times. So what's popular is specific heat capacity and the transfer of thermal energy. So you should know the formula for specific heat capacity, which is the energy equals mass times specific heat capacity times change in the temperature. You should understand this formula and know how to manipulate it. So I've also went through this formula in my video, in my crash course video. So make sure to check that out. What's also been increasingly popular is conversion between degrees Celsius and Kelvin. So to convert between Celsius to Kelvin, you just add 273. And from Kelvins to degrees Celsius, just subtract 273. This is a simple conversion, but I've seen it come up a lot. And just so you know, the three ways of transfer of thermal energies are: the first one is conduction, second one is convection, and third one is radiation. These are the three main ways of transfer of thermal energy. Now, waves. Waves is one of the biggest topics in the paper 4 So we're looking around at a whopping 21%, which is around 30 marks. So this could get you from a B to an A or from a C to a B. So make sure to know this topic very well. If you're not sure about waves, I've gone through the whole topics of waves, and I'll leave the link down below. So make sure to go through that if you're not sure about waves, because this is a very important topic. What they can ask you about the different properties of waves, and you should know the difference between the longitudinal waves and the transverse waves. You should know their difference and examples for each. And the second one is lights. So a light is very popular, and what I've seen in recent years is they would give you ray diagrams. So you can have like a lens at the center, and then you have the principal axis, and then you can have like an image, and they can tell you to draw the the image of the object. Let's say this is object O. They can tell us to draw the image of the object. So make sure you know how to do this. The third one is electromagnetic spectrum. So you should know the different waves in the electromagnetic spectrum, which are the gamma rays, the X rays, the light rays, the infrared. There are multiple of them, so make sure to know their properties and make sure to know some of the uses of those. The next one is sound waves. Sound waves, they're a type of longitudinal waves, and you should know the speed of sound in air, which is 330 meters per second. And also, what I've seen is that sound waves are not that popular compared to light waves. So lights questions about light are like guaranteed to come. So make sure you truly understand the topic. And also, when we're looking at light, we have reflection, and then we have refraction, and also diffraction. So make sure to know what these three terms mean and understand them. Next one is wave diagrams. So they can give you different types of wave diagrams. This is one of the wave diagrams I've been talking about. And they can also give you diagrams for refraction or reflection. So they can give you a diagram like this and ask you to calculate the refractive index given these two angles, or different types of questions. Electricity and magnetism. This is the biggest topic. So make sure you truly understand this topic, because this can make or break your grades. We're looking at 25% of the paper. So it's like 1/4 of the paper is electricity and magnetism. So make sure you understand this topic. I can't stress this enough. Takes about 50 marks of the paper. So what can they ask you? They can ask about electric charges, so negative charge, positive charge, and how they interact. But this is very uncommon. The most common part is the electric circuits and circuit components. This is almost a guarantee to come. It's guaranteed to come. So if there's electricity question, this type of question with electric circuit is guaranteed to come. So you need to know a few formulas, which is current is equals to charge over time. The next one is voltage is equals to IR, current times resistance. The next formula is power equals to VI, and electrical energy equals it's IVT. So I'll go in depth into these formulas on my crash course video. So if you don't really understand what these formulas mean, make sure to check that out. And when we look at magnetism, it has not been coming up recently. It's very rare for it to come. But what's been popular is the electromagnetic effect. So I would predict that this would also come. So mainly we're looking at transformers and generators slash motors. So especially transformers, make sure to know how how a transformer works, because electric circuits and electromagnetic effect, they're the ones that show up. Number 9, nuclear physics. So nuclear physics, it's a big part of the paper too, but it's 15% of the paper, which is about 9 marks. So what can they ask you? They can ask about the atom. So make sure you know, let's say if we have an atom and we have the mass number and the atomic number. So this is the number of protons. This is the number of protons plus neutrons. Make sure you know this. And they can ask you they can maybe give you the mass number, and they can ask you to determine the proton numbers. Next one is radioactivity. So most radioactivity topics are related to radioactive decay and count rate. So there are three types of radioactive decays. The first one is an alpha decay, beta decay, and gamma decay. So make sure you know the equations for this ones, and you understand which one is which and what happens in these three equations. So equations of decay, it's a very popular topic. It could come, and you should also know the differences between alpha particles, beta particles, and gamma particles. So just a quick run through. An alpha particle, it has a mass number of 4 and 2 protons. A beta particle is basically a high speed electron. So it has 0 mass number and atomic number of -1. And gamma ray, as we know, it's an electromagnetic radiation. So it has 0 mass and 0 charge either too. So this is the quick recap on the three particles. And the half-life graphs. Now I haven't seen these in a long time. So they've been decreasing in popularity in recent years, but they could still come. So make sure to know how to interpret a half-life graph. So what they give you is they give you a graph, and then they can ask you to determine the half-life graph. Okay, the half-life of the maybe the atom or the nucleus from the graph. So make sure you know how to interpret this. The last topic is space physics. Now this is a new topic introduced in the 2023 syllabus, yet it has been increasing in popularity. So it takes about 17% of the paper, which is 10 marks. And what they ask, so they can ask on the earth and the moon, but the earth, okay, so they can ask you like the distance, okay, the maybe the speed of revolution. So maybe they can give you the distance between the earth and the moon. Let's say this is the earth, this is the moon, and they give you the distance d, and also the radius to the center r, and they can ask you to find the speed. So the speed formula is pi dr over the time taken. So because it's the moon is moving in a circular motion, the total distance is like the circumference of the circle. So circumference is pi times the radius. So this whole line dr, so pi d plus r, sorry, it's pi d plus r. So that's the formula for the speed of revolution. And also you should know about the solar system. And then like we have like 8 planets surround rotating revolving around the sun, and life cycle of a star. Now this has been coming a lot recently, so make sure to know the details of the life cycle of a star. So there are different stages of the life cycle of a star. So if you're not sure about space physics, I have a dedicated space physics video which I'll link down below. So make sure to check it out. The last one they can ask you, it's very popular. It's the universe and Hubble's constant. So Hubble's constant is Hubble's constant, the formula is the distance over the speed. So it's measured in seconds minus 1, and the value is 2.27 times 10 to the power of minus 18. But you don't need to memorize this, as if there's a question about Hubble's constant, the Hubble's constant would be given. And Hubble's constant could be used to determine the age of the universe. So that was it for this video. I hope you have enjoyed and learned from this video. If you have any questions or comments, make sure to drop them down below in the comment section. And thank you for watching. And good luck on your exams coming up.